So let's discuss directly our analysis and discussion. So for our first discussion, the sum of two consecutive numbers is an odd number. So as you can see in the table, 1 plus 2, so 1 here is the odd number and the even number is 2. So when you're going to add even or an odd number, the result will always be odd number. So example, 1 plus 2 equals 3, 2 plus 3 equals 5, and 4 plus 5 is 9. So we can conclude that these results are true. So when you select two consecutive numbers, you'll always get one each since odd and even numbers are alternated. So for our analysis 4.2, if three consecutive numbers are added together, the total is multiple of 3. So when you are going to add three consecutive numbers, example 1 plus 2 plus 3 equals 6, 2 plus 3 plus 4 equals 9, 3 plus 4 plus 5 equals 12, 4 plus 5 plus 6 equals 15. So we can observe that the results are a multiple of 3. So 6 divided by 3 equals 2, 9 divided by 3 equals 3, and 12 divided by 3 is 4. As you can see in the table, you can easily identify that the sum of three consecutive numbers being added is a multiple of 3. So for our analysis 4.3, the sum of 4 consecutive whole numbers are even numbers that had an odd number as half of its total. So for example, 1 plus 2 plus 3 plus 4 equals 10, and 2 plus 3 plus 4 plus 5, the sum is 14. 3 plus 4 plus 5 plus 6 equals 18. 4 plus 5 plus 6 plus 7 equals to 22. So we can conclude that from this discovered series of numbers from 10, 14, 18, 22, 26, and so on, may be obtained by adding 4 consecutive integers. For example, the sum of 1, 2, 3, and 4, so 10. And the next sum of adding also 4 consecutive numbers is 14. So the sum of each answers is being added by 4. We discovered that the series of numbers 10, 14, 18, 22, and 26, and so on, may be obtained by adding 4 consecutive integers. So each of these had an odd number as the other half of the sum. So moreover, there is a 4 difference between their sums.
So continuing, we have now our table 4.4. So the sum of 5 consecutive whole number is divisible by 5. So if you are going to add 5 consecutive numbers, whole counting numbers, we will have a number that is divisible by 5. So let's see in our table, we have here 15 as their sum of 1, 2, 3, 4, 5, and 20, 25. And as you can see in our table, it is all divisible by 5. That means you can divide your sum by 5. Numbers which are multiples by 5, starting with 15, are the sum of 5 consecutive numbers, as I've said earlier. We can also say that x plus the quantity of x plus 1 plus the quantity of x plus 2 plus the quantity of x plus 3 plus the quantity of x plus 4 is equal to 5x plus 10, which is that expression is also divisible by 5. When you're going to divide that expression by 5, we will obtain x plus 2, which is its median. Next is the sum of 6 consecutive whole number. The sum of 6 consecutive whole number is divisible by the sum of the two middle numbers. So if you're going to have 6 terms over here, 6 consecutive terms, the sum of their two middle numbers is divisible by its sum. So if you're going to divide the sum by the middle two numbers, it will result to a whole number. So let the 6 number be, or let the 6 terms be x plus 1 plus x plus 2 plus x plus 3 plus x plus 4 plus x plus 5. Their sum is 6x plus 15. And the sum of their two middle terms is 2n plus 5. So, we can also equate that 6x plus 15 is equal to 3 multiplied to 2n plus 5, wherein 2n plus 5 is our median or the sum of two middle numbers. Example in a sequence 1, 2, 3, 4, 5 plus 6. Their sum is 21. So the two middle numbers here is 4 and 3, which will result to 7. If you're going to add 4 and 3, it will result to 7. Then 21, we can conclude that 21 is also divisible by 7. Therefore, the conjecture is true that the sum of the consecutive terms is divisible by the sum of two middle numbers. So let's have another example. We have here a sequence 9 plus 10 plus 11 plus 12 plus 13 plus 14. The sum is 69 and the two middle numbers are 12 and 11. If you're going to add 12 and 11, we will obtain 23. 69 divided by 23 is 3.
So for our analysis, 4.6, representing numbers as sum of consecutive numbers. So 1, 2, 4, 8, 16, and 32, there is no sum of consecutive numbers for them. So we conclude that any counting number that is not equal to 1 and 2 raised to the power of n can be expressed as the sum of two or more consecutive counting whole numbers. So just like 3, there is a sum of two consecutive numbers which are 1 and 2. So for 5, 2 plus 3. For number 6, 1 plus 2 plus 3 plus for 7 is 3 plus 4 and so on, as you can see in the table being given. So for the process in finding S, which is our analysis 4.7, the formula for solving an odd number of terms is that S, which is the sum of consecutive terms, is equal to N, which is the number of terms, and multiplied to M, which is the median of the sequence. Formula for solving an odd number of terms is that S, which is the sum of consecutive terms, is equal to N, which is the number of terms, and multiplied to M, which is the median of the sequence. In solving for even number of terms, we are going to use is that S equals to N multiplied to the quantity of M sub 1 plus M sub 2 all over 2. So 2 here is constant. So where N is the number of terms, M sub 1 is the median, the first median, M sub 2 is the second median, and S is the sum of the consecutive.